Introducing a point mutation in PCR, also known as site-directed mutagenesis, involves designing primers with desired nucleotide changes and using them in a PCR reaction to amplify the target DNA. The key to site-directed mutagenesis is the designing the right set of the primers that incorporate your desired mutation. These primers will contain a single nucleotide mismatch at the position where the mutation is intended to be introduced. The primer should also contain enough nucleotides flanking the mutation site to allow for accurate amplification of the target DNA. With whole plasmid site-directed mutagenesis, a set of complementary primers with the desired mutations are designed and used to amplify the entire plasmid by PCR. The PCR product will contain the mutation. Keep note when setting up the PCR reaction to use a high fidelity polymerase. These polymerases are designed to replicate DNA with very low error rates and are crucial to minimize unwanted mutations during the amplification process. Next, we add the DPN1 restriction enzyme to break down the original template DNA. DPN1 cuts only methylated DNA which comes from bacteria. The new PCR product is not methylated, so it stays intact. Once ready, the PCR product is ready to transform into competent cell. However, when you transform this into the E. coli competent cell, the bacteria repair enzymes repair these nicks and creates whole plasmid. The designing primer can be easily done in the SnapGene software. Now suppose we take this plasmid and we designed a set of the site-directed mutagenesis primer. Now highlighted what changes I need to make. Now I added a feature. We are replacing G to T. Now I'll select the 45 base pair long. I will select the 50 base pair on each side of this change and where the mutation is changes should be taking place. Now I'll go to primers and I will add primers, and I will start by creating a primer using the top strand first. And now need to change the G to T, my intended mutation. Notice how the new base pair looks mismatched. Now I need to add the complementary primers. So I will copy the top strand and I will add new primers, then select reverse complement, and it's as simple as that. Coming back, introducing a mutation into linear DNA product is slightly different. It can be achieved with site-directed mutagenesis by overlap extension PCR. To do this, you will need to run several PCR reactions using 4 primers that amplify the regions flanking your mutation site. The first PCR reaction will amplify the upstream fragment, incorporating the mutation at its 3' end. The second PCR reaction amplifies the downstream fragments, incorporating the mutation at its 5' end. Both fragments will overlap at the site of mutation. In the final step, combine both PCR product and reform another PCR using the outermost primers. This allows the overlapping fragments to anneal and extend into a single full-length product that contains your desired mutations. If you find this video helpful, please give it a thumbs up and please subscribe the channel. Feel free to leave any questions you may have in the comment section and I'll be happy to